Okay, now it's started to record. Okay. Now see, yesterday what we had discussed regarding the thing, so I wanted to show you the diagram. Then in today's lecture, I basically want to finish the module 4 we'll finish today. Okay. There are
Yes, sir.
module 4, there are two numericals only, but rest all is,
Yes, sir.
but you have to, you see, you need good visualization to understand.
Sir.
Good visual, that's why I provided you with the diagram. So if you look,
Right, sir.
yeah, if you look at this particular system, okay, so here is basically the NAN, that is neighborhood area network, okay.
Sir.
This is basically the premises network wherein you have your household, everything. This incorporates your premises network, and I have shared with you the books also from where the notes have been made by your teacher. Okay,
Yes, sir. Yes, sir. Yes, sir. I saw,
so
sir.
one book, Ekanaike, he is following for this. Ekanaike book is there. Okay,
Okay.
and that you book is in your Gmail. Okay, you can go through it.
Yes, sir.
Okay, so from here, basically, what happens is that this is the generation part. Okay, distributed generation. Wherein what he is doing is that with this here you are seeing, this is basically the power electronic
Converter.
converter. Okay, with this power electronic converter, na,
Yes, sir.
by varying its duty ratio, you understand duty ratio? Duty
Sir.
T on by total T on
Yes,
plus
sir.
T off. Okay, duty ratio value is between 0 to 1. Okay,
Right, sir.
suppose I keep the duty ratio, I set duty ratio 2D minus 1 is my duty ratio, is my
Uh,
duty ratio. And I want power system, not for this system, it should be in a standby mode. Standby mode would mean neither it should supply power nor it should uh, charge. Neither it should supply
now should it charge?
nor should it charge.
Okay.
Charge what? Charge the battery.
Yes, sir.
Battery. So this is called a standby mode or an idle mode. In the ideal mode, my D value can range between 0 to zero point 0.1. I will keep at 0.5. So
Hmm.
keeping this as 0.5, so 2 into zero point 0.5 minus 1. So my duty ratio again becomes 0. So it is not affecting the system. Okay. So
Okay.
this system, see, my output current, my
Yes, sir.
output, in other words, my V output voltage would be equal
Uh,
to duty ratio into V input. Okay.
okay.
Only when my duty ratio would be, see, if my duty ratio is zero point 0.6, okay, at
Yes, sir.
that time you see, if I keep, let's suppose my duty, let it be zero point 0.6. At that
Okay.
time, see, the formula is 2D minus 1, right? Okay,
Uh,
this is basically duty ratio, DR. Let
okay.
me keep it as DR, duty ratio, DR. So the
Okay.
formula is
Okay.
basically 2D minus 1 into V in. So at this scenario, you see this would be 1.2 minus 1 into V in. Okay, so
Uh,
this is the time you will see that this is zero point 0.2 into V in. Okay, so at this time when my duty ratio is zero point 0.6, it will start to, okay, charge, because okay, but if my duty ratio is less than zero point 0.5, like suppose it's zero point 0.4, then it will become 0.8. 2 into D is 2 into zero point 0.4, 0.8 minus 1 into V in. At that time I get a negative value, minus zero point
hmm.
0.2 V in. So that means my V output, that is the output from the grid. So the grid has
Yeah.
charge. Okay. So this is the condition for discharge. Although it is not relevant, like I'm giving you because you have worked in battery management system. Okay.
Yes, sir.
So this network over here, electrical, you can see the electrical vehicle connection, then battery connection, okay, to the grid, and
Sir.
these are the transformer links and all. This is the feeder and all. So this is the primarily the connection which you are seeing, which is created locally. This connection, battery connection, this connection, then solar PV, electrical vehicle. These are like movable devices. All are movable, right? These are all
Yes, sir.
movable, and these can be utilized. These are movable. and can be utilized, huh? Can be
Yes, sir.
utilized as a source. Okay, I'll
Okay.
keep the annotations as it is. This is PowerPoint. Okay, I'll send you the annotations.
Ha, sir. No worries, sir.
Okay, okay. So you can see this, but here you can see this is the actual. See, if you see here, this is where the actual generation takes place. This is the actual generation, actual power station. Okay, wherein you have the
Ha, sir.
generation, then grid. Okay, then you have
Okay.
transmission network. Okay, then you have the substation. Then you have SCADA is called as this SCADA abbreviation is supervisory supervisory control data data
Accusation.
acquisition system. Okay, this is the full form of this supervisory
Okay, sir.
data acquisition system. So this is basically the primary thing. So you can see there is one SCADA network here. Okay, then look, see there's a wind farm which is connected over here. Okay, so and
Yes, sir.
then it comes to the here SCADA, and you have a large photovoltaic plant again which is connected to the SCADA. Okay, so here
Okay.
this thing you can see here, over here, right? This is then
Ha,
connected
sir.
to the local control rooms and the neighborhood networks, and from the neighborhood networks, basically the connection comes in there is a wide area network, then it is coming back to the neighborhood network. From the neighborhood network, only this you can see Han, they have only mentioned Han is the house area network, which is a part of premises network, right? It,
Yes, sir. Yes, sir.
yeah, they have only mentioned hand, but see, yeah, there is industrial. See, they have mentioned the house and all. It can be a small industrial unit or some business unit also. So all the three can be there. There can be ban also there. There can be IAN also there. In the no this thing they have only mentioned. After that, once these things are happening, then you have to see that, see, there are some other local providers also, like Reliance Power, okay, uh, uh, like Adani Power.
Ha.
Okay, these are local providers also. So these are
Okay.
other providers. These other providers are also providing. Okay, but what power they are providing? What is the information? And there is the system from the main grid. So this information is stored in the this internet. Okay, in the in the internet, in the communication channel. Okay, in the
Okay.
communication channel. So this communication channel, basically this channel follows some protocols and has some layers. Okay, so herein there is the communication channel. I hope that you are understanding. Hmm?
Yes, sir. Sir, one second, sir. Sir,
Uh,
even like you said, even these Ambanis or
hmm.
Adani Power, they'll also have to abide by the 812
Yeah,
one
yeah,
five six.
exactly. Yeah, there are certain in South Korea or in the US or in Canada, they
Ah,
have
sir.
they are abiding by the rules, but they have sometimes they have their own protocols also. Okay,
Uh,
but those
like
protocols,
a corporate set of protocols.
no, those protocols are taken on a common base. See, suppose the
Okay.
normal protocol is the base protocol, and their protocols
Correct.
would be compared to that, somewhat like in per unit system, and it would be like for charging and for marketing. Those would be basically for the pricing, for the billing purposes.
Sir.
Like India exports petroleum at rupees 30. Okay, per
Okay.
per liter, but it sells at, it has all rules of GST, this thing, that thing. Similarly, those market dealers are sending it, and it has to, at a common base, they have to look at that. Okay, on top
Okay.
of that, government would have certain policies based on that only. Those protocols would be on a baseline with the actual protocols. Okay,
Okay.
because they
Okay.
have to
Okay.
follow, otherwise there would be chaos and confusion.
Correct. Of course, sir. That's what.
Okay, it has to be on a same base. Okay,
Uh,
so now let me move to the next slide. Can I move?
yes, sir. Yes, sir.
Yeah. So this is your teacher only. So whatever is teaching here. So here you see that basically here you can see there is a, yeah. So in order to get this, there's a switch. Okay, this switch
Okay.
can be a physical switch. Okay, physical switch, or it can be virtual switch. But normally, can you tell me what is the difference between a router and a modem? See, router and modem. See, modem
Um.
is having
Yeah.
an
Yes, sir.
particular IP address. Okay, it is modem is given to one location. Okay,
Okay.
wherein with the help of the router, okay, router you can connect to many hosts. Like you have a router at your home, you can do a
Sir.
physical LAN connection with the help of the router. Okay,
Uh,
modem is the thing which is bringing internet to your home. Modem brings internet to your home. It is having a unique network ID. Okay,
okay.
network ID and a host ID. So this is like bringing internet to your home. Okay. Now one more very internet to your home. One more very important concept here would be, see, so many messages are getting to. Can I switch over?
Yes, sir. Yes, sir.
Hello, can you hear me?
Uh, yes, sir. Yes, sir. Sir,
Okay.
at the
Your
end of the
voice is
class,
not
can you send this?
clear. Yeah, hello.
Sir, at the end of this class, can
Huh?
you send a? Sir, hello,
My
can you
voice
hear
is
me?
clear,
Yes, sir. Yes, sir.
but why your voice is little low? I'm not able to hear.
Can you
Okay.
hear me, sir?
Yeah. So
Uh,
if I will move to that Zigbee part wala later. Let me just, yeah. So basically, when we are going for the communication purposes, okay. So this is our channel. Okay, this is the source from where there's an input transducer. What exact is the function of a transducer? Transducer is basically a form of sensor. Okay, what it does, it converts one form one form to another. Like if
okay.
you have a speed transducer or a volt, it can convert speed to voltage. Okay, so you have this analog data measurements. Okay, analog data measurements can be converted to discrete. Okay, because the computer will only understand binary. Computer
Hmm.
only understands binary. Computer only understands 0 and 1 format. So you have
Correct.
an input transducer, and this from here, after you convert this analog to binary, then this signal can be transmitted. So there's a transmitter, okay, and
Okay.
this for the transmitted signal, then you have this transmission channel. In the transmission channel only, see, you have this three things I told you: the network channel, and the second part was the communication, and then the third part was the protocol. So after the
Yeah.
transmission, there would be receiver, and at the output also, in what form you want. Suppose in the input you have in form of voice. Okay. So voice you are feeding it, and then you are converting this into digital signal. Okay, digital. At the
Okay.
output signal also you are having digital. Okay, but you want it back in the destination also in the form of voice. So here,
Okay.
hello, Pronal, can you hear me?
Yes, sir. Sir, can you not hear me?
Yeah, I'm able to hear. You are able to hear me clearly?
Yes, sir. Clearly, sir.
Okay, so suppose I have
Sir,
a,
sir, one second. I want to ask if you could send me the this PowerPoint at the end of the class.
yeah, definitely. With annotations, I will send you. Okay.
Yes, sir. Yes. Thank you, sir.
Whatever your teacher has taught, that only I have to explain you with the annotations.
Sir.
Okay, what we will finish the entire fourth module today. Okay, don't worry.
Okay, sir. Okay, sir.
So I will at the end, I will suppose this is your voice. Okay, after the
Yes, sir.
voice signal, because see in that Zoom and all, this is a PPT, so nothing. Don't worry about it. I need not require to
Ah,
save it. Okay,
okay, sir. Okay, sir.
annotations. I
Thank you,
will
sir.
keep the annotations and I will send you. See, this is
Yes, sir.
suppose you're giving a phone call. Okay, and there is a voice. This voice you need to convert in the form of electrical signals. Okay,
Correct.
digital
Yes, sir.
signal. Those electrical signals cannot go in form of voltage or current. Those also
Hmm.
need to be connected in the form of binary data, right? So it
Yeah,
should
yeah,
be
yeah.
connected in form of binary data. Then it is transmitted in a transmission channel. The transmission channel can be either wired, okay, that is
Okay.
the phone. Earlier phones used to be wired, right? or it
Yes, sir.
nowadays you see with the invent of the mobile technology, it can be wireless. Wireless
Okay.
technology basically like uses the towers. Okay, towers are placed, and it is there is a satellite here. Okay, satellite, so it is sending it into the free space. From here, tower is receiving the signal, it is going again back to the tower. Okay, and nearby you are having a mobile phone. So from here, you like this is Pronal's phone. Okay,
Yes, sir.
and this is Dr. Zaid talking. Okay, Dr.
Yes,
Zaid.
sir.
So this is how it is happening. It is going to the satellite. Okay, signal is going to the satellite. From the satellite, it is going reflecting back to the tower. It is catching it. Okay, but when it is going, there is some amount of noise in the air. Noise in air.
Okay.
Okay,
Uh,
noise in air. So that noise will be, to eliminate that noise. There are aliasing filters. Aliasing
okay.
filters. Now you see we are talking from almost 3,500 kilometers. I'm sitting in
Correct.
Kashmir, the northernmost part. You are sitting in Kerala, but still the noise is very clear because we are
Yes,
putting
sir.
the filters and all. So this is how the
Okay.
communication channel is working. Okay,
I got it.
okay. Now see, then there are different type of operations. Like there is like, see, in the transmitter also you have to like, see, when you are transmitting a signal, your signal should be your main signal should be your receiving signal should be twice the sending signal. Okay, for this we use certain modulation techniques. Okay, that is called pulse width modulation. Then there is coding. Okay, coding techniques. And
Okay.
at the receiver we need amplification of the voice. Okay, it should be
Okay.
amplification would mean it should be boosted, and
Okay.
it should be there would be a lot of atmospheric
Okay.
noise. So this atmospheric
Okay.
noise would require filtering. Okay, once this filtering is done, this signal needs to be converted back to the original signal. Conversion back to original, back to original, and then decoding it. Okay, and then decoding it, and the person is receiving. Okay, finally message is received. Message is received. So this is how the signal movement goes. Okay, don't worry, I'm
Got
going
it,
to
sir.
send you. Don't worry, I'm going a little fast because I want to see.
Finish it off.
Yeah, there are, see, you are having, see, radio, see, simplex transmission, radio and TV broadcasting you are having, right? In
Yes,
radio
sir.
and TV you must have seen UHV, VHF,
Sir.
sorry, UHF, VHF. So UHF means, see, in VHF you will get the nearby channels and all very good channels like Star Plus and all. So if here you will get DD Kerala, something like that. Okay, mostly the free channels.
Okay.
Okay, here in the VHF frequency band you will get the paid ones. Okay, in the
Correct.
earlier times, now there is the invent of Tata Sky. If you have cable at your home, cable you can find this thing UHF and VHF. You go for
Hmm.
the search. Okay, and you'll
Okay.
get UHF means ultra high frequency. Okay,
Oh, okay. Okay. Exactly.
ultra high frequency, and this VHF stands for very high frequency, very high
Oh,
frequency.
frequency.
So these frequencies are having a bandwidth. Again, I have told you. So these frequencies are ranging like, say this is 10,000 to some 1 lakh. So these frequencies. So from here you are having a bandwidth. This is the channel bandwidth. So this bandwidth will give you the capacity of the channel. Okay, this is the capacity. Okay, so at 1,001 hertz you can have a channel, or at 1,050 you can have another channel like this. So like if you see, there is like, when you are using the telephone, so we use a duplex communication. Okay, from both sides. Okay, you are having
Okay.
basically a communication here. You are having a tower, you are having another phone, you are having a tower. So this is receiving here, then this is transmitting here, then this is going back here. So this type of arrangement is called full duplex transmission. Whereas when you are using radio transmissions, like in military or like in police and all, so in that scenario,
Yes, sir.
you are not having at a secondary source, you are not having like this kind of an arrangement. You are only having, you are having a particular thing, you are giving it to the satellite. From here is a walkie talkie, okay, because you can be in
Okay.
jungle, okay, because you can be at a place, okay, where
That you
this
won't get a
arrangement,
range.
where range is not there, where tower installment is not there, tower installment
Okay.
is not there. So these, basically these will use non-line of sight. This is called non-line of sight arrangement, and this is
Okay.
this line of sight arrangement basically, okay. So this is how it is done, okay.
Okay,
So
sir.
now you see the full duplex transmission. Just I have explained you. Okay, from one side is calling, from other side is receiving. So now see again, I have explained you the message must be converted to form of a for the particular type of communication system. Same thing. So here he has written silly in electrical speech waves are converted by a microphone to a voltage variation. I told you the speech. Firstly, the speech would be converted to voltage. So, but this voltage, now the transmitter to produce signals of the transmission channel. Now what happens that this voltage signal of our transmission, what happens is that it will involve the modulation. Okay, this voltage he has not written would be converted to bits form. Okay, and this would be,
Okay.
see, I will tell you, like we have this 8421 coding system. Suppose in the
Okay.
binary form I want to write 5 volts, right? I can
Ah.
write this in form of 0, 1, 0, 1. How it is done? See, basically, whatever the value, this is the binary value. Okay,
Yes, sir.
this is the coding system, right? This is the coding system. So
Correct.
if I
Correct.
have to write, so I will do 8 into 0 plus 4 into 1 plus 2 into 0 plus 1 into 1. So 8 into 0 becomes 0, this becomes 4, this becomes 0, this becomes 1. So totally I get 5 volts. On similar basis, if I want to write, I can write up to 15 volts. But 15 volts in the binary, it is represented as FF. In the binary, if it is 8 bit,
That is right.
represented at
F.
FF.
F.
For 8 bit, it is represented at FF. So the decimal
Okay.
conversion of FF, if you put binary and the decimal conversion of it would be 255. Okay, you can have
Okay.
a calculator. Okay, calculator is with
Yes,
you.
sir. Yes, sir. I have it, sir.
Huh?
I have it, sir. Yes, sir.
Yeah, you put the base value in the base. You put base as by in form of binary FF. Then you convert it to
Okay.
decimal. You will get 255. Okay, that is for 8
Okay,
bit
sir.
transmission. For 16 bit, it goes from FFF, from 16 bit. So the start value can be from 0 to FF. This is for 8 bit transmission. 8 bit transmission. Okay, and for
Okay.
16 bit it starts from, see, start from 0 0 0 0 to F F F F. See, in the later part I'll explain you this by this
Okay.
thing, you note. When our class finishes, you try with this and you try that binary to decimal conversion. So once this coding is done, in addition to modulation, we will do the modulation. Now we need to again amplify this signal so that the voice is not lost. So we signal should be boosted. Okay. Once we are boosting, we are also boosting what? The noise, the atmospheric noise that was present in the
Yeah.
system. To
Yeah. Yeah. Yeah.
eliminate the noise, to eliminate noise, filtering is used. Filters. Okay, that is called as
Okay.
anti aliasing filters. Okay. Hello, Pranil, are you there?
Yes, yes, sir. I can hear you,
Yeah.
sir.
Yeah, anti-aliasing filters are there. So you noted down this. Note down
Yes, sir.
8
I'm
bit
writing it down.
00 to FF for 16 bit. It is the range of the signal will be from 000. This is the start point. Okay, this is the start point. I will write as SP start point, and this would be the end point. End point. Okay.
Yes, sir.
Hmm?
1 second, sir.
Yeah. Can I move to the next slide?
Sir, 1 second, sir. 1 second. 1 second.
Yeah, you take it down. I'm going a little fast because I want to complete. 4th June is your exam year, or is it delayed, or is it on time?
Sir, as of now, they've not given
As of
any
now,
update. So, sir, as of now, they've not given any update. So, I think it could be
okay, it's a
delayed.
tentative timetable. Okay.
Yes, sir. Sir, they had said it could possibly
See,
start from
can you
4th.
speak a little closer to the mic?
Sir, they had said that they
Yeah, I'm
could
not able to
possibly.
hear you.
Sir, can you hear me
Huh?
now? Sir, can you hear me now?
Now I can hear you. Yeah.
Sir, they had said that it could possibly start from 4th, which is why I told you 4th. So as
Okay.
of now, they've not given the proper date yet. But so considering that
Okay.
it's already
Okay.
20th, I think they're probably going to delay it.
Hmm.
Yeah.
Hello.
Yes, sir. Yes.
My,
Yes, sir. Yes, sir.
my voice should be clear. Your voice sometimes the pitch is good, sometimes it's going down. I don't know. Anyways, can I move to the next slide?
Yes, sir. Yes, sir.
Yeah, now it's correct. Okay. Now see, the thing is that now transmission we need the channel, so there should be a particular channel, a medium, a path like the road is there for the car to proceed on it. Similarly, for the transmission of the signal, we need a channel. So the channel can be we can utilize the atmosphere as well, the free space. That would be definitely when we are using the atmosphere. That primarily would be your free space, okay, and it would be your wireless connection. It is not possible with the wire connection, so this would be done via wireless, wherein you are transmitting a signal which is received at a satellite, okay, and it is refracted back to some tower. So this kind is possible with the advancement of the wireless technology. Okay, so now in this is like, but what about the wired? So for the wired, we have coaxial cable, which was earlier used in the phones. Okay, when in the 90s the phones were there. Okay, wherein we had to, you might not have been born there. Trunk call. Okay, we have to place a trunk call, wait for the person. Now there is an invent of fiber optic. Okay, and still more progression is there in the form of the waveguide. So this signal will definitely, when we are sending it, it will go some degradation, okay, and interference and issues. So this will lead to signal to noise ratio, signal to noise. Okay, so we need to
Yes, sir.
eliminate this noise. Okay, eliminate noise. So one thing is there, the receiver will be there. Okay, in the receiver again, it will extract the signal, okay, convert it into a suitable form. Then there is the output transducer, which will convert the electrical signal at its input to the form desired by the system user. For example, we have a loudspeaker or a PC or tape recorder. Okay, we can convert. So there are different type of communications, mostly the speech signal, the voice signal, which are continuous in time. These are called as analog communication system. So the information is transmitted in continuous form, whereas the digital, or we can say the discrete systems, which are like sampled at some intervals, which can be placed. So this is, see, if I draw this, this is my discrete signal. Sorry, this is my uh, analog system, analog. But the same analog system can be represented in discrete form by seeing the value at each point. Okay, so this is value at one, yeah, let me, this is the value at another point, value at this point, value at this point, value at this point. So I can draw this system somewhat like this. So this discrete system can be represented in binary form, 0 to 1 form. Okay, but analog signal cannot be written. So this, because of the advancement of discrete system, this can be stored in computers. Okay, and computer can interrupt it. So we will be using basically the digital communication. Okay, the input signal must be sampled from its analog form. Okay, Now, what are the advantages? Advantages of the digital in comparison to analog is that we can use coding methods. Okay, as I told you, it can be digitally processed with the help of the
Yes, yes, sir.
computers, and also it will, because it is sampling at particular, it is not taking every, like every which way, so it has better resistivity against noise. So now the physical limitations. Now I again told you bandwidth is raised as of C. Where is it? So we have a transmission bandwidth. So what does this transmission bandwidth do? Can you tell me? Hmm?
Sir, it
This, see, we have a frequency spectrum of the transmitted signal. Okay, and
okay.
this will define the maximum speed of variation of the so nowadays you have 5 gigahertz of 5 gigahertz in your phone. Earlier it was coming 2.4 gigahertz, right? So this is basically the bandwidth of the frequency signal. More the bandwidth, less the time. Okay, less time, because time is inversely proportional to frequency. So this would be 1 by 5 into 10 power 9. So 1 by 5 is equal to how much? Zero point 0.2. So this would be zero point 0.2 nanoseconds. Whereas if you see, if I keep it as 2.5, it would be more. Okay, 1 by 2.5, 1 by 2.5 is zero point 0.4 nanoseconds. So the operation, a particular operation in your mobile, any application you are opening inside your mobile phone, it will take zero point 0.2 nanoseconds if you have a frequency of 5 gigahertz. Okay, so that means if you have a larger bandwidth, so large data can be transmitted. Okay, data transmission possible, transmission possible. So you are talking about the WiMAX and all that. In the WiMAX, I will be going to it. So you can transmit 300 MBs of data. Okay, 300 MB per second. Okay, now if you, yeah, can I move? The
Yes,
time,
yes, sir.
so I have explained you mathematically. Here he has told the time required for transmission of given amount of information is inversely proportional to the transmission bandwidth. See here, this is the time, and this is the, we can say time is equal to 1 by bandwidth. Okay, so if the bandwidth increases, time will decrease. So we can safely say if bandwidth increases, time of operation and signal transmission increases. Okay, so can I move?
Yes, sir.
Yeah. So whatever, see, these things I've already discussed. Okay, communication and all that. So this noise and all I told you. So now let's this one once we had done in the very beginning, but now it's coming here. So let's do this one more time, and you see there is lot of things there. Okay, so I have to teach you
हाँ सर,
according to the syllabus only. So that's why I decided.
हाँ सर,
Okay, this is your channel. Okay, earlier I talked to you the Gauss flow. Now it was not there. It is there, but it is only a theoretical part. Okay, only the DC load flow I saw was in that part. So this is your, see, the rate of information transfer cannot exceed the channel capacity. So you have some capacity. Okay, if you
yes sir,
have a capacity of channel like 10 megabits per second, so you cannot transfer at a faster rate. You cannot transfer at 100 megabits per second. Okay, it will not transfer. Okay, why it will not transfer? Can you tell me? Hmm? Because it is not in that zone only. Na? It is not in that bandwidth zone only. If you are, because it will not
oh,
remain in that zone. So for that, now you have, see, for that, your channel maximum channel capacity in bits per second is given by a formula that was derived by Shannon. Based upon this Shannon's law only, we have the modern phone. Okay, modern phone which we are utilizing today is based upon this formula only. Okay, and then they have done advancement, and based upon this formula only, the modern phone which you are having today is because of the Shannon's work. So you have this Maximum channel capacity is given in bits per second. So this is the formula. C is equal to B log to the base 2 1 plus Sn. So this Sn is basically signal to noise ratio. This is signal to noise ratio, right? This is signal to noise ratio. Have you taken down this formula? Can I move?
Just writing down, sir.
Yeah, please take down this formula. Once you take down this formula, we will do one numerical. Okay,
Okay, sir.
I think, yeah, I have to finish that numerical in this session only. 3 minutes 35 seconds are left, but I want to complete that. Then immediately I'll send you the next link.
Yes, sir.
Okay, can we move?
Yes, sir.
Okay, now see, there is an example here which is mentioning that we are having a bandwidth. See, B value it is giving us 400 hertz. So this can be expressed in 4 kilohertz. And it is saying that the signal to noise ratio is 20 dB. Okay, 20 dB. So this 20 dB, this one more formula. See, earlier you had this formula C is equal to how much? B log to the base 2 1 plus signal to noise ratio. Okay, this is your channel
Okay.
capacity. Now this signal to noise ratio can be expressed in form of dBs. Okay, this is one more formula. 20 dB is expressed as 10 log to the base. You see here, log to the base 10 signal to noise ratio. No, and this is typically 20 dB. Okay, have you taken it down?
Yes, sir. I have written it down, sir.
Yeah. So now what is telling that your log 10 to the base is telling that okay, your log 10 to the base s to the power n is equal to 2. Okay. So
Okay, sir.
what you do is take log on both the sides. When you take log on both the sides, so it will become log 2. Okay. So
Sir.
this log will get over. So see, log 10 is equal to 1, right? And log
Yeah.
100 is equal to 2. You can put in your calculator. Okay, this you can put in the calculator. Similarly, log 1000 is equal to 3. Okay, so this log 100 minus log 10 will give you a value of 1. So this value is called as 1 decade. We are not interested, but just simply I told you. Okay, so
Okay,
when you are putting the log on the both sides, so you know that this logarithmic value is getting cancelled. So if I take this log on the other side, this log 2, so basically 100 log 100 is equal to 2. So this I can simply say that my 100 is equal to 9 because it eliminates my signal to noise ratio. 100 would be equal to S power n. So yeah, now I have this channel capacity.
Sir, one second. Sir, can you go back to the previous slide?
Yeah,
1 minute.
yeah. Tell me.
Or sir, can you go back to the previous slide?
Yeah.
Actually,
See, let me finish this. Then I'll let me finish this because
yes,
we
sir.
are
Yes, sir.
hardly left. It will. Yeah, where it went.
Sir,
Yeah.
behind. Sir.
See, now here you will straight away put this 4000 hertz log to the base 2 1 plus 100. Okay. If you calculate log to the base 2 1 plus 100, multiply it for 4000, you'll get an answer of 26.63 kilobit.
Kilobit per second.
Okay, kilobit per second. Okay. So
So,
the,
sir, one second, sir. So the decade is log
what is the
100
difference
to
between
minus log
bit
10.
and byte? 8 bits is equal to 1 byte.